get ready for it.
All right, we're going.
Good. Good morning. Just some current business we have to talk about. We currently have 63 paid members, and we have approximately $2,134 in the bank. Also, we need to talk about the excuse me, the scholarship. We haven't given it out in quite some time, so we need to think about if we still want to keep it going. I'll refresh the application. So we were giving out $250 once a year, but we need to see if everybody still is interested in doing it. So if we are, just let me know and we'll get it started again. Also, Jason wanted to remind everybody, we're going to leave all the YouTube videos online till January 1st for all paid members. So you have up to then, and you're going to delete them, and we'll start over again. Also, if anybody has more speakers, at least bring them to us so we can get more people in here talking, so we can get the CUs up. Also, the CEUs before 2019 for 1 and 2 operators, I want to remind everybody, they are not getting credit. We're not getting credit for them. But the way we understand it, the 3 and 4s are getting credit for the 19 CEU hours. So just something to remind everybody of. Also, for anybody that's members of the Illinois Rural Water Association, they're not doing much with wastewater anymore. Their conference they have coming up has 0 wastewater. So I'm asking everybody, if you are members, get hold of your rep and make a complaint. They're supposed to be for wastewater too. It's kind of went on deaf ears. I've called them several times, and we're right now at the point where we're going to just drop out of it. And we've been members probably since they started. If they're not going to do wastewater stuff, I have no need for it. So I want to introduce John Jacobs with WTR, and I'll let him take over.
Okay, sure. Where's the pointer at? Oh, there it is. Get back to the beginning here. A little delay action here. Yes, my name's John Jacobs. I'm with WTR Solutions. Been in the business for over 20 years, dealing with waste lagoons, waste management. Done everything from grease traps to restaurants to CAFOs, industrial waste, rendering plants. Been doing a lot of egg operations in Wisconsin, Iowa, Ohio, etc. We also do different types of waste as far as breweries and wineries even. You know, I actually enjoy going to a brewery and winery because then I can have a drink when I'm done messing with their lagoons. So, but, you know, this is kind of a two-part. At first here, I'm going to talk about your sludge management for your lagoons. You know, your lagoons and the investment that your city and your community made is an asset. And really you need to retain that asset, and the only way to do that is to maintain your lagoons. Now, some of these lagoons are 20 years old or 30 years old, whatever, and if we haven't done anything
Why
yet
should I measure the sludge in my
lagoon? Trouble
lagoon?
down the road. So
Well,
I'll be kicking the can down the road, basically. So once your asset actually turns into a liability, then that's when you become a problem, because now you have to meet the new standards. The EPA has been really good about moving that threshold, right? Now we have to meet a 6-part DO. Back in the day, it was only a 2-part DO. Now with phosphorus being another issue, we have to consider other types of treatment to get rid of your phosphorus even. And of course, ammonia now has been a more strict problem.
Without
for all
quantifying
of
the
us.
volume of your
And,
sludge,
so
how
we
can
gotta
you manage the
keep track
sludge?
of what
Therefore, we
can
need
do
to know
better.
the sludge
There's
volume
other
to
technologies
better
out
manage
there.
it.
There's
By
better
knowing
ways
your
of
sludge volume,
implementing
you can
those
determine its
technologies to
value.
your system, your existing
Lagoons
system,
are an
which is always
asset.
good. It's always
We
cheaper
hire
that way
engineers to design them
versus,
according to your
starting
population
all
and
over.
growth.
In some cases,
We
if
pay
your town is growing,
contractors
you're
to
gonna need
construct
to
them,
start
and we
over
hire
probably a good
wastewater
thing.
operators such as yourselves to run them,
if it's-
operate them,
Like
and
I said, if
maintain.
it's been the system around 50 years, it's probably time to make a change.
The old
So-
money wave, right?
Why should I measure the
Estimate
sludge?
communities'
in my lagoon?
li-
Well, there's many reasons why we need to do that, because if you become full of sludge, then now your retention time and your treatment is going to be less and less. So with that in mind, we also need to measure it to estimate what it's going to cost the community to remove that sludge. And, that's not exactly cheap, or is it better off to abandon that and move on? Again, we got to look at what's going to cost the
Liability.
community.
Make no mistake.
So my
Then we
sludge
have all
lagoon,
the chiefs that
uh,
you as
determine the
operators
cost
need to
of
talk
what that
to,
is
and,
gonna-
and engineers might be
removing that
involved
sludge.
as well.
Again, what
in
are some of your
determining
upgrade
the cost
choices?
of removing sludge
Can
from
you
lagoon
actually get rid
is
of
a
it?
must-know
Okay.
for future planning.
There's more than one way of getting rid of it. One way is to mechanically get rid of it, or biologically. Some of these lagoons, being a controlled discharge, a lot of them don't have any aeration. Why not? Okay, that'd be a good way of actually getting rid of some of your solids. We're always talking about volatiles. Okay.
Knowing the
Your,
cost of such a large project
Minerals and
must
stuff
be
like that are
planned
never
for years.
digestible. You can separate them, but
Once the
they're never
sludge
digestible.
volume is
So
determined,
anytime we go out to a
the
lagoon,
next
we're always
step
doing
is
the
to
TS
conduct
and the VS
testing
on the
so
sludge.
the
We need to take those
ergonomic
samples.
rate of sludge
So
can
in order
be
to do
calculated.
that, we got to determine, measure up your lagoon, your
So I
width,
want to
your
measure
length,
my
your width,
lagoon's
and
sludge
depth of
buildup.
everything. And then we have to
How do I
understand
get
what's
started?
actually going on in that lagoon.
Well,
So,
the best way would be to
and some that is
look at
what's
your
slope
lagoon's
as well.
engineering drawings.
But once you have
Usually those are
the
hard to
main
find,
area of your lagoon,
and they might be
now you need to measure.
the first
So
drawing.
you go out there, you make a grid
Usually I
pattern.
never see a
We've all
as-built
done
drawing,
this, or
which
we've just gone out
be the
and-
most
and
accurate.
randomly taken a
But,
sludge judge.
if that
and
lagoon is
see what we
30
have.
plus years old,
But if you actually do it
that
properly,
lagoon
you
has
want to put
changed
it into
anyway.
a grid, whether that's we
the
used to do
slopes
it
may
with
have been earthen, and now it
a
has
poly rope
river rock
that
on
went
it.
across the lagoon.
So
We
it's
measure
been
out every
changed.
50 feet or 100 feet, whatever that was, and then we put
So,
a knot
in order to
every
start
50
out,
feet or 30
The next
feet,
step
whatever
is to
that may be as
determine
well.
if you want to
That way, when you went
conduct a
across
sludge
in the
survey
boat,
yourself.
you would be at that exact point or a good grid. Now, you can also use a GPS and this and that, but I always find the rope gave the operator a place to stay and do your measurement. GPS, you usually needed two people.
Or if you
to
want
keep the boat
to
in that exact
contract a
area.
professional.
So that if you want to go back 2 years from
And
now or 5
sometimes
years from
it's
now,
cheaper
if you still have that
to
rope,
contract
you
somebody
just roll
else,
off the rope and do it again.
or if you
But,
want good information, that's your
so-
other option.
Again.
But if you
need sludge
choose to
judge,
do it yourself,
you need
well,
somebody
you're going to
write
need the
down, or
following.
if you in the
You
boat
need
or
to set up a
somebody on
grid
the
pattern
embankment.
by using the
They
length and the
also
width
make
and the depth
little,
again.
I've
for your
used
draw.
this. It's called it's a little sonar
So,
for fishing.
Once you establish
It's an
your
app on your
grid
phone.
with
It'll
markers,
come up and
you
you'll
need to
actually
do the
kinda measure
following.
what your sludge is as
And
well.
the more people you have to do this,
Completely accurate.
the
but,
easier it
gives
is.
you an idea how deep that sludge is.
Usually, we just do it with a
Safety, rubber
two-man
gloves,
boat,
rubber
but there's
boots,
only
safety
one
glasses.
person in that boat
And I can't
with the
emphasize on
sludge
this
judge.
enough right now because right
Then
now there's a
another
lot of testing
person is
going on with the COVID
on the embankment
problem.
with the
And
clipboard
a lot of our
and-
wastewater
and
has
pen
COVID
and paper,
in it.
whatever.
Okay, so
And
you need to be careful out
he's
there
marking down the information.
when you're dealing with your wastewater.
You have a boat, motor, life jacket,
This is a
jacket.
typical sludge
if you need
judge
it.
that I use.
If you need the motor anyway.
It's a
If you use the
bigger
rope,
unit.
like I mentioned,
And I actually make
you really
measurements
don't
on
need the
this
battery and the
every
rope.
2 inches, so I can get pretty accurate. When you get one of these, This is out of USA Blue Book. I believe the number's up there. There you go. They modified the bottom of this. And the bottom of this, you don't see this ball thing anymore. I've actually cut this off about a ½ inch. So when you get one of these, it's actually flush. Now you got to bring it clear up, put your finger underneath that to get the sludge out of it, okay? For mechanical operators, usually you should pull it up, put it down on hard surface, and you're done. Well, you're not going to be able to do that with the new one that they came out with. So, but anyway. So that's my sludge judge. I mark it off so that we get a little more accuracy. Yeah, you always end up with getting new bottoms. I always carry more than one of these along because you can't break it. Anything over 15 feet, you need to separate it every time you come up. So that's how we do it. So anyway, you got everything measured up, you got where you want, now you're going to go out for a boat ride, right? Well, that's always fun, go out there and
Bon voyage, right?
We've all done it. I've done it
So
for
before you
many
ship
years
out,
myself.
and
And
measure your
guess what?
sludge,
There's
you need to
actually
know how
really
to
an
use a
easier
sludge
way.
judge properly.
Some of the tools that you need are right there. You need
Again, here's a two-man
I
boat.
use a two-man boat. It's small. The wind doesn't
this
catch
one here
it.
has a
I can maneuver pretty easily. Measuring wheel, sample. You're going to grab samples as well, so you're going to have those out there with you. As far as your sludge samples, depending how big the lagoon is, you may want to separate those from front to back. So, so again, you'll need to know how deep your lagoon is. That
Sludge Judge
how many sections
101.
you will need, of course.
What you will need to
Keep
know
away from
how
your
deep
sides.
your lagoon
The
is.
deeper it is,
This
the further
determines how many
out away from the
sections you will
embankment
need.
to be.
So if you only have
The
a
slope will
10-foot
give you
section
false information.
or 10 feet deep, then you
And try
only
to
need
pick a
2
day that's
sections
not
with
windy. That's always a
the
challenge,
sludge
right?
judge.
Or you do it early in the morning before it picks up and get one of them done or whatever needs to be. And of course, make sure you plug up your boat, right? Have you done that anyway?
Senior.
Knock on wood. So now when you collect all your data, now you're going to have something of information put together. And
Well,
with all your data
you collected all your
end up,
data, now what?
with an average of your lagoon, etc.
If you collected all the data points on your lagoon grid,
far as your
you should
volume
be able to
sludge
see
and
something
all
that
that.
resembles a checkerboard with
so
random
that
numbers
seems
in
like
each box.
a lot of work.
Okay.
It is. It'll
Next,
take you a day or
create
two,
a
depending
spreadsheet and
on
place
how
all the
active
data
wanna
you
be.
collected into spreadsheet.
Is
and
there an
average
easier way? Of course there is. Because now there's
Well,
technology out there
That seems like a
is a
lot.
remote control boat. There's sonar.
Well, here's the newest and
collects
greatest
data points every
technology
second that
for
boat
doing
is traveling.
sludge surveys, people.
Okay. So
The
that
newest
helps
technology for
tremendously.
conducting sludge
We did
surveys
a site
is the use of a
Ashland,
remote
Illinois,
control
actually.
boat.
Had the operator, the city manager there, and another representative of the Illinois Rural Water. We did it by hand. We measured out with a rope and everything else, and went back there about 3 months later, 4 months later, and we put the sonar boat out there, and we missed it.
Is collecting
Okay?
a
We
data
had
point
50-foot
every
grids,
second.
and we still missed half of
And
the
that data
solids
point
that
is
were
being
actually out there.
recorded onto
we
an
missed where
SD
the
card.
inlet was, basically.
So every
But we can always
second
tell you where the inlet is.
that boat travels
So,
about 5 to 7
by
feet apart. And
gathering
that
all
all
this
depends how
information,
fast
because now
the boat is being
you're
operated
going to end
at.
up with
The slower it
hundreds of data
is,
points.
the
Now,
more
this
data
is
points
a
are going to be
waypoint of the
closer
boat.
to.
This is actually Ashton. I'll just let you know.
So here's a
Of course, you have all
sonar
this
path.
equipment in your way.
Um,
Okay.
Each one of
So-
those numbers represents the depth
excuse me.
of the water
But
to the
up
solids.
here in the
A sonar can
software,
only see.
here's how
to
many
the
data
earth,
points we ended up
basically.
with. We ended up with
So from the surface of the
667
water
data points.
to the
And what
surface of the
This is
solids
measuring
is that
is
measurement that
from
you
the surface of the
see.
water,
And so
from the surface
the
of the
numbers-
water to the top of the solids. Okay? So these numbers right here are actually the depth of the water down to the solids. Now the total depth of this is actually 12 feet. Okay. When you come down here to the results, it'll give you your average height of your liquid and your average height of your solids. So the average solid was just over 3 feet in this lagoon. And this is their primary lagoon. They have some of these old tornadoes. I think there's only 2 of them that were working at the time. And that's the other thing. Before you do this, you always want to shut off your equipment. If you have a blower system and things like that, you need to let it set for about 24 hours before we come in with a sonar. A little bit longer is always better, because with a blower system that's stirring it up really heavy, you got to let it all settle. Otherwise, you'll get some false information. So when you're all said and done, it already automatically gives you cubic feet of solids. All right, so we know we have 234,000 cubic feet of solids we need to get rid of. The other reason that we do this, and what's nice about this is this took all of probably 30, 40 minutes to do this one lagoon. And it takes about another 20 minutes or a half hour to actually put a report together on it, but that's okay. But again, we're collecting hundreds of data points with the sonar boat, and it really doesn't matter how randomly that boat is, it's going to average all those things out, okay? So that's the great thing about the new technology of a sonar boat. This is just another different site. You can do, again, just a random path. We did 726 data points. The average height of the liquid was 13.3, and the solids was 1.1. Really not much of a reason to do really anything with this as far as sludge removal. Really in pretty good shape. But again, without this information, you're going to be kind of wondering. Let me get to another slide here. So this one here is the 3D look of it. And this one here, we collected over 1,100 data points, okay? This particular site, an average of 7 feet of 0.2 liquid and 4.5 feet of solids on average. We can also tell you where those solids are. With this scale over here, the red is actually where it's higher, okay? The blue is where it's more depth, of the water. So the scale tells you, like over in here, we're around 10 feet of water here, where we only have about 4 to 5 feet of water above the solids over in this area. The other thing that helps you with that is if you're going to augment it with, now we have these bio tablets and different things that, companies have come up with it, which I think is great. Now you can actually get in that area and actually apply that product to that area, okay? Instead of applying it throughout the lagoon, which is a waste of money and material, now you can go in and attack the area that you need to, because a lot of these tablets and a lot of the product will sink into that solids, and it has an enzyme bacteria inside that helps break down the solids. So, but anyway, that's the other reason to actually do that. Sun Valley Lake is a private lake down in southern Iowa. This is a controlled discharge site. This is cell 3. It's all pointed out up here. This is a direct overhead view, like if you're looking down at it. And I can tell you where their outlet is. And I can tell you where their inlet is, okay? This here goes to 2 more lagoons. So when they drain it, it's actually pulling your solids away from that area, okay? Same thing if we can look at your solids where they're accumulating, which is usually around the inlet. I was down at Mackinac, just not far from here, last year. Mike was trying to figure out where the inlet pipe was, and so we could figure out with all these measurements about where that pipe was. So again, it kind of becomes a good value of knowing where your pipes are in the lagoon. So again, this one here, these are controlled discharge, so there wasn't much liquid in here, basically just 3 feet. And so out of the 3 feet, there's about a foot of solids in here. So each one will have a different scale in each cell when you do it, as far as what you're seeing as far as depth of water. This is a side view of it. Again, we can turn this on the software however you want to look at it, from top, side, whatever. So again, what we're seeing here on the side view is where this comes. This is all water. Everything below this is all solids. So this is the portfolio of that lagoon. Okay. This is City of Ackley. This is one of our first sites we did clear back in '02. The city people service is the contracting there. And on average, they actually did all the sludge judging there. And they had an average of 30 inches of solids in there, in their first lagoon. And we implemented a different technology to it and went back there in 2019 with the sonar boat to see, what's been going on. So right now you can tell this is the inlet, obviously, with the spike out there. But the rest of it's all flat as can be, in which, on average, we only have a foot of solids out there. This used to be 30 inches, okay, years ago. So again, a benefit of looking at it with a sonar boat, as far as introducing your byproducts or a different technology, if you're adding aeration to your lagoon, et cetera, whether it's enzymes, bacteria, you can go back and see with a sonar boat a lot quicker and a lot easier as to has that product done anything for me, okay? If you're leasing equipment, you can say, well, let's lease it for a year, come back and sonar it, and see if it actually helped. If it didn't, get out of the lease and move on, right? No harm, no foul, et cetera. Didn't hurt you any. This is another city site as far as measurements. This is actually cell 1 down here. They have a blower system. It's not doing too well. A lot of them are plugged up, et cetera. So we have a average liquid of 7, average solids of 4.5. Okay. Now you get to the second cell, not much in there. So at least we know we're keeping it all in cell 1 as well. Okay. This site here, they could actually use some additional type of air other than it all being here and just a few in here, So I know they're upgrading. It's progress. One of the other things to do with the solids, this is just a formula that we have that, when you send in your TS and the VS to the lab to have an analyzed for your volatiles, you're going to have these numbers. So we plug all this information in, give us the total pounds of volatile solids, dry weight, et cetera, okay? Now you can come back, again, if you do this a year later, if you're treating it or have changed something, you want to take that solids, because sometimes your depth of your solids aren't going to change. They're going to be fluffier. And I've come across that with a sludge judge even. If you go into your lagoon and it's a little stiff to put that sludge judge through, and then if you apply whatever product or technology that you've done, and you go back 6 months or a year, and if you can put that sludge judge through that sludge a lot easier and feel the bottom, you know you're on the right path. Now, we've done a couple of these where the sonar didn't pick up any real different in depth of the solids, but the TS and the VS came up with 40,000 or 70,000 pounds difference, okay? Because a lot of times what's happening when you're treating it with the technology or enzyme bacteria, it'll actually start breaking, the bacteria will actually start breaking up those solids and bringing it in suspension, okay? So that's what kind of happens with, when you're doing different treatment or different operations, different plants. So some things that we monitor with these lagoons is we always need to be monitoring. If you don't monitor on a weekly or monthly or whatever that base is, it's going to be difficult. You know, if you make a phone call and say, hey, I'm having a problem with my lagoon, well, I'm going to ask you, well, what's your DO? What's your temperatures? What's your pH? Do you know what your ammonias are? Do you know, you know, what just reading what's coming in and what's reading going out doesn't mean anything. You really need to be reading every individual lagoon to know what you need to do to it. Without any data in between it, you're just going to be throwing a dart on the board and see what sticks, okay? So you really need to be looking at data from each individual lagoon in order to figure out which one is the problem. Maybe you're not getting any ammonia removal in your first lagoon, but you are in your second one. Why? Well, you need to take some data. We do TDS and total organic carbons. You can get really sophisticated with your samples, but if you have a problem, it's a good place to start. So I always look at plate counts even, all right? HPC or sim plate. It's just the total number of bacteria. Bacteria are in there for a reason, okay? They're in there to treat your water, all right? They're a carbon like you and me. Well, guess what's happened in 2020, all right? COVID happened, and all these gallons of bleach and sanitizers went down your drain, all right? They had pallets of bleaches and sanitizers in Walmart and stores, and you all used them, all right? And about every lagoon has been killed out there because of COVID, all right? So it's one of the things that you need to be considering is looking at how healthy your lagoon is, all right? We use this all the time to measure lagoons. I've come across many of them that don't even have a 30,000 plate count. I've come across some like in egg operations. Egg operations are cleaning their equipment every day, sometimes 3 or 4 times a day. They use sanitizers, bleaches, acids to clean their equipment. So what does that do? It kills all their bacteria in their water stream. And it ends up out in the lagoon, then you're trying to figure out why you're not getting anything done. So take a look at that. Now, HPC or sim plate is the same thing as your fecal bottle. You know, you got 24 hours to get to your lab, and you want a true number. You know, you don't want a greater number or it's less than 2,000 or greater than 2,000. That doesn't mean anything. If it's less than 2,000, you got a problem anyway, okay? But I've always had to correct the lab, say, no, I need a real number, okay? So make sure you put that on the remarks. They may have to dilute it 3 or 4 times if you have a high plate count. So, you know, make sure you get a good number. Now, it's just something you know, again, it gives you a starting point. So, let me back up here a little bit. So by collecting your baseline, it gives you a profile of your lagoon, right? Doesn't matter if you do it once a year, just do it, all right? It gives you some information that you can go back and look at. So, you know, whether it's every month, like I said, every 4 months, it'd be better. You know, every other month would be great because your cold water, you know, your winter months versus your summer months are going to react differently, obviously. So with the sonar information and the TS and the VS, this was one of the treatment options that we provided for one of our clients. And basically from August of 2018 to December of 19, these are all the different numbers that we have changed, you know, the blue being, of course, in 18. This down here is in 19, the end of the year. So again, you know, the water level never really changes much, but the sludge average did. This was from the sonar over here on the right. And then as far as the TS and the VS, the results from the lab was also documented, which is over here. So again, you know, using an RC sonar boat, we can be a little safer at it. It's more accurate, gives you hundreds and thousands of data points. gives you the location of your sludge to actually treat it. There is also a gentleman, Robert Risley. He's down in Centralia. He also has a sonar boat, so that can be. And he also has product that he can help you with your lagoons as well. The cost on doing the sonar boat, it's around $1,100 depending on size and distance we have to travel, et cetera. But we're going to go out there and boat, get your samples for you. We always confirm what I always do with the flow judge, make sure the information that the boat's gathering, that it's accurate as well. So, again, this is just different information on sonar and graphs. Again, we can tell you where everything's at in that lagoon. So that's the end of the sludge and sonar gathering. So we'll take a short break here. In about 5 minutes here, and we'll put up the other technology that I'm going to be talking about. Thank you. Are we doing okay, Jay? Slammed it on the floor and broke my sludge judge. The little pin that goes through here. Just let me know when you're ready. Are you good? Well, that was short, 5 minutes. All right, going to talk about microbubble diffusion. It's actually been around for over 20 years I've been dealing with. Now today there's actually a couple other companies that are doing the same thing. They're making a bubble that sinks in the water. And so that's what's different about it. We're doing the same thing as any other aeration equipment is doing, and that is we're putting oxygen in the water. This equipment here is a little easier to install. It's usually installed in a day's time, up and operating. Obviously, you need electricity, and that's about the only thing we need. We take it from there. One thing about this type of technology, we're actually creating every bubble there is. We're creating nano bubbles, micro bubbles, larger bubbles, and bubbles that actually go to the surface. Sometimes we're looking at mixing. A lot of places say you got to keep it all mixed up. Well, that also defeats with the plate count and the bacteria. You're trying to move. If you're mixing that water so bad, you're moving the dinner table for the bacteria then. But so my background, wastewater treatment, different methods, the nature of the waste, treating it, what's the operating cost, all those things that, are you landlocked, can you expand or not, okay? So part of this, as far as the MBD, as far as nanobubbles and microbubbles, is under kind of a wave theory, and it creates a cloud of bubbles. So what happens is we're introducing the oxygen or the air below the surface of the water. We're only doing it about a foot below the surface of the water. So, 80 to 90% of the samples measured are 250 or less. So, but the air is actually trapped by the water molecule itself. and the water actually has pressure to it. But when you introduce this air below the surface of the water, it's under a partial vacuum. That air is under a partial vacuum. And so by creating that negative pressure, I got ahead of myself here, and introducing that water, we're actually using a louver that's actually making the space in the water itself below. And then at that same point, the air is being injected into that water, while the water molecule actually traps that air then at that point. And what it does then, it creates these bubbles underwater. All right? Now these bubbles, you know, this is just a little 1-inch, 3/4 inch little demo unit. It's no bigger than my thumb. And these bubbles are actually traveling from this point to that point by diffusion. Okay? There's only so much space in that water to hold that air bubble. It's just like this room that we're in. If more people kept coming in, if we start over there in that corner, we're eventually going to be over in this corner. Okay? And that's what these air bubbles do. They flow with the water, which is actually another advantage, is that it's going to be throughout your lagoon or throughout your mechanical plant. They're going to travel with the stream. Now this is just in 10 seconds when this thing was turned on. So that bubble is a non-buoyant. It's entrained between the water molecules. Takes on the same identity as the water molecules. So again, you know, just like we are in air, these air bubbles are in water. So it allows us to have unlimited dispersion of these air bubbles throughout a stream or a lagoon. So they become their own identity in the water. And of course, we know what BOD is. You know, these are all things that we need to be looking at in our stream. You know, your TS and VS is more of your sludge application again. But without this information, again, you need to be doing this for every cell, in my opinion. Some of the other things that you need to look at is your fat flow and grease. Like I said, we've done operations with grease traps. We've done large cafeteria ones for like John Deere, mainly because of odor issues. Nobody wanted to go to the cafeteria to eat. So, but anyway, different technology we can put in. Sometimes you need to put in a DAF unit, dissolved air flotation type unit. Again, these are things that you can add to your system without taking up a big space. You know, they're a small footprint, help you with phosphorus removal or ammonia removals as well. Same thing with MBBR, a moving bed biological reactor. These are going to be probably a little more common coming up because of our phosphorus limits that we're going to have to meet, along with your ammonias. You know, they have a good place to be in your system, okay? So dissolved oxygen is important to determine the stability of your water. One of the other things to look at as far as dissolved oxygen is your ORP, oxygen reduction potential. We'll come across that here too. So organic or pollutants have a negative influence, okay? Of course, warmer water, less oxygen, colder water is easier. Algae in plants, you know, algae will put off oxygen during the day. I was just at a site yesterday, and it's at 19, but the water is green as can be. To me, that's a false DO information to help anything. Now, without doing a little more investigating, see what the plate count is and see what kind of reduction we're getting, you know, that's from that point forward. So oxygen, you know, helps obviously decrease our BODs. It's all about the organics, your bacteria, to help reduce all that. And just like us, we need air, food, and water. Well, oxygen is usually the one thing that your bacteria are depleted of. We know they have plenty of food. We know they have plenty of water. So each waste stream and everybody's lagoon is unique in itself. I can't go from one town to another and be exactly the same. It could be exactly the same design, but I don't know what you're doing with your water. What type of, is it harder? It even starts with your water side of things, okay? So, what we need to know is, again, testing is important to compare it, all right? You may go along, this usually happens with CAFOs or like my egg operations. They'll be on a daily basis 3,000 or 4,000 BOD loading. Then all of a sudden becomes 14,000 BOD loading, okay? Well, now all of a sudden that's a big surge on your system. And do you have enough equipment there to take over that? So again, if there's a company, a town, or a plant, whatever, I remember a story from somebody else saying that they drained their, I think it was a hotel that drained their pool. Well, it had all kinds of chlorine in it and everything else in it, and it upset their mechanical plant, okay? So, it's good to keep everybody informed or them to inform you what they're going to be doing, all right? So, here's a typical molecule characteristic in the wastewater. You have your oxygen bonds, your hydrogen bonds. It's just a structure. Really water has a lot of energy to it, all right? Excuse me. The significance about this is that everything has a positive and negative charge to it, all right? Obviously. But it's this distance that gives the space to put oxygen in. And the dirtier the water is, the worse this is, okay? So it's a fixed distance of the binding of the hydrogen bonds and the fixed distance that gives the space. And again, it's just a process of wastewater. It takes 3,000 calories to break the CO2 bond. If you ever put a piece of board on top of your water or anything, it takes a little energy to pull that board off, right? That's what's going on under the water as well. It's a bond, and you got to break that bond. So this is a typical water molecule, all right? Again, it has 2 hydrogen bonds and 1 oxygen bond. It becomes our H2O. Again, we're looking at this distance in between everything, the positive charge and negative charge of it. Again, just another diagram of how they arrange themselves. And this has all been measured even, all right? What's interesting is when you freeze that water, they all become perfectly patternized, right? In liquid water, they're arranged differently, and then in a vapor, they're all over the place. Again, now this is a salt molecule that's been introduced. And when you put a salt crystal in there, it interrupts all these water molecules. So again, if we also measure salinity in a lot of our water. Egg operations are terrible at. Anytime you have a industry, a food processing plant, whatever, they use a lot of salt, okay? And this is going to interrupt and interfere with your aeration equipment or how it performs. So you may be blowing the heck out of it, but you might only be using a good 50% of it because your salt or salinity is so high, it cannot overcome that. So your salt is a real problem out there. Now, phosphate and sulfurs are oxygen scavengers as well. So there's different scavengers out there that are taking up oxygen as well. And you got to identify those. Again, pH is a good one. ORP is another benefit of a test. This scale here just represents different X-rays of the molecules. A bacteria is 0.2. Crystals, a human hair. Bacteria come down in this area of the scale. Reverse osmosis. We have a lot of reverse osmosis things out there, right? For our drinking water. Here's reverse osmosis. Here's a membrane, a filter. It's trapping all your dirty water. It's holding it back, right? All the fresh water is still going through. Give you an idea, here's a membrane pores of a reverse osmosis. Here's the size of your bacteria and viruses. And what do you do with that in a reverse osmosis? You backflush it, right? Where does it go? Out to the waste stream, right? That's probably not a real good place for it to go, okay? Especially nowadays. If you could put that backflush into a filtering bed of some sort or something else for it to evaporate off, that'd be a better place to divert it to, okay? It might be only 1,000 gallons, might be 10,000 gallons, I don't know. But it's something to think about. Again, the bubble size, all right? If you got a low pressure gas bubble, the pressure of the water is going to collapse around it. If you have a high pressure blower type bubble, it's going to rise, okay? Again, these are different bubble measurements. So the MBD is producing all these different bubbles, okay? A nanobubble, and to be honest, we didn't know we were doing a nanobubble until we got a big laser on it. And we were actually at a conference next to a guy that was promoting nanobubbles, okay? And he was intrigued of what we were doing so simply. And so he brought his laser down, and we didn't turn it on right away. He wanted to see what it looked like overnight. And so he flashed this big laser in there, and he goes, "You're producing nanobubbles." And we've been doing it for 20 years and didn't know it. So kind of interesting who you run into sometimes. But anyway, we found we were doing every bubble there is. Again, this is really what we're seeing here are microbubbles. The nanobubbles are even smaller yet, okay? And you with the light and the black backdrop, this is the best we can do, okay? So this is just, again, a little close-up of it. And then, again, they're traveling by diffusion. So they're taking up space throughout a water cavity, per se. So it's pretty well filled up. Again, that's the reason that they travel, is because the bubble is under a negative pressure or a vacuum versus a pressure bubble. A pressure bubble obviously just raises. Again, so I'm going to just emphasize we're introducing that air under a vacuum in the pressure of the water. And so the water actually makes those small bubbles for us. It just crushes them down. This is just a different, again, a forced air bubble. And these are micro bubbles down here. And so, we can put about 4,000 of these small bubbles into a forced air bubble. Well, what that does, now we have a surface area. We have a higher surface area with all these bubbles versus the one big bubble. So that gives us more area of oxygen in that water. This is just a cut sheet, a typical a 1-horse, 2-horse, and a 5-horse. Our 2-horse is the most easiest and popular unit that we put in. We're putting over 400 pounds of oxygen per day with that unit, which is tremendous for a 2-horse. This is a egg operation. It's in the winter, obviously, and it's just a different application or a design of the install. What do we need? Well, we need tools of trade, we need charts, we need references, we need graphs, we need comparisons to know what we have going on in our system. Again, we need to collect some data. Everybody has one of these on their wall, right? Somewhere? To know what you have in your stream. You can get them out of USA Blue Book. I feel like I'm advertising for USA Blue Book, but they're a good source of information, and they have all kinds of fun stuff. But if you have a microscope and you have different bacteria that you're trying to identify, this is a good place to start. These are your basic ones. So. Well, we need a DO beaner. That's always a good one to start with. pH meter. If you're not balanced, it's just like us. We'll get sick. We don't feel good. Same thing with your bacteria. ORP, oxygen reduction potential. It's a handheld meter as well. Salinity. Some of these meters come, like all in one. HPC is a good source to be identified, to know what type of bacteria you have. You can take a sample to a lab, and they can also identify your different bacteria. We've done this in the past to know what's healthy, which ones are healthy, which ones are there, etc. Keeping good records and reports are always good because it gives you basic information if you want to go back and look at what happened. Be consistent with it. And these are, again, these are just some of your test equipment. This one here is like a 4-in-1. So it does pH, TDC, conductivity, and salinity. And then they have separate ones. This is an ORP. This is a salinity, of course, a DO meter. But you can get all these put together and not spend $1,000, okay? If you get this one here, I don't know if they have it anymore. I think they've discontinued it, to be honest. But, it's a couple $100, So it's not as accurate what a Hawk meter is going to be, but it gets you in the ballpark, okay? At least gets you on the dartboard, I guess. Again, ORP, oxygen reduction potential. What does that mean? Well, anything that's a negative, if you're clear down here in the methane production, you got a problem, okay? The higher you go, the better off you are. A positive rate, now you have good biochemical reaction going on. Again, salinity is the amount of salt in the water, organic material, which may be a negatively charged and positive ions in the water. Salinity is kind of important. TDS, total dissolved solids, all right? Now, what's funny about all these is that it's just another information on ORP. I'm going to go back one. What's interesting about all these meters, a DO meter is different, but on the end of these, there's just a little electron probe. And what it's actually doing is measuring that conductivity in that water. And they're just set at a different scale to understand what you're measuring. Okay, so the positive and negative is what they're using to come up with a result on these meters. All right, kind of ironic, but that's how that happens. All right, testing and understanding your sludge. Kind of mentioned this before. We need to understand the nutrients of that sludge. Sometimes we're doing, we do some sludge testing for engineers because they want to see what the 503 fees are. So that's all your metals and everything else to land apply it as well. Your total solids, your volatile solids, the percentage of that as far as what's volatile. Again, your minerals. And as far as lagoons, we're talking about retention time affects your treatment time. All right. Unlike a mechanical plant, a mechanical plant is actually separating the waste right away in a 24-hour period or 12-hour period, whatever that may be. So they're trying to separate it, and that's why they're usually an activated sludge plant, because now they have a tank full of sludge they got to get rid of because biologically they didn't get it completed. That's just the way it has to be. When you're doing millions of gallons a day or 10 million gallons a day, that's your choice. Polymers. Polymers are fine to thicken your sludge at the end of your treatment, but never before. It becomes it's a silicon, it's man-made product. It becomes a waste in your stream. And it will, this happened to one of my clients. They're using polymers to thicken their sludge, to land apply it. they spent a couple $1 million on a reed bed, a brand new reed bed. And I actually told them, they had a tank left of probably only 10,000 gallons, or no, it was 20,000 gallons. And I said, well, whatever you do, take that out to the field yet. And they're like, well, yeah, but we just spent a couple $1 million on this reed bed. I said, you don't want to put it out there, it'll suffocate it. They went ahead and did it, and it did exactly what I said. It killed their reed bed, brand new reed bed. They had to redo it, okay? So polymers, yeah, they do their job of thickening up sludge, and they do other things out there as well. But you never want to do it at the beginning of a treatment, you know, because it's going to affect your aeration, et cetera. You always want to do it at the end. Sorry, we talked about sonar boat imaging earlier. This is one of our treatment sites, a rendering plant out in Ohio that we did. It's a rendering plant. You know, all the turkey guts and everything else that comes into the site. In 40 days, we took it from that to that. These are all 5-horse units, by the way. This lagoon was only 4 feet deep to begin with. And come find out, I was number 3 trying to solve their problem, which was interesting. Didn't know that at the time. But this is all floating fat, soil, and grease as well, as far as what we started off with. And then, again, that's what it ended up being. This equipment is actually clear on the other end. And on the other end is the inlet area. But we affected the whole lagoon, okay? Because, again, those air bubbles are traveling clear across this lagoon because there's only so much space in there. The other thing that they were doing is they were taking the TS and the VS on the solids, okay? I'm sorry, yeah, it was 5.5 feet deep. I thought it was 3.5. Never mind. That's what they ended up doing. That's what was in my mind. So anyway, again, depth of the sludge. And the depth of the sludge is actually from our sonar information, okay? So that's our average. And so we had, you know, over 3 million gallons of sludge in there, all right? Shoot. So what happened in 110 days at this rendering plant with the MBD is we took out over 1 million gallons of solids in 110 days. Now, there's no chemicals in this, it's all natural, you know, biological, it just went to town. Got rid of the odor issues as well, okay? Anytime you're getting rid of the odors, you're getting treatment. MBBR, talked about this again, moving bed biofilm reactor. You know, this is going to be probably a more, again, become mainstream with a lot of these plants or even lagoons to get rid of their ammoniums and their phosphorus. So keep that in mind. You know, it's an air diffuser placed near at the bottom, just keep it all kind of mixed up again. Even though they're trying to create bacteria, you want to slough off as well. So again, it helps the media moving to control the oxygen transfer and solid sloughing. You know, and you got to work with that. You know, it isn't like you just turn on the switch and it automatically does it. You got to play with these things. And depending on what you have in your stream, you're going to play with it again. All right? That's why you got to be on top of these as well. One thing about their small footprint, it's a continuous process. It has a wide range of industries as far as the application. It's nutrient reduction, and again, they don't take up much energy. They're going to take up more energy than what you started off with, but again, it helps with your bacteria as well. So these are some of the, you know, little blocks that are in it. Bacteria grow inside these things. That's why they got to kind of keep them moving, put a little bit of air through it, etc. This is one that was installed in Bloomingdale, Michigan, back in 2013. So this is all this gunk on here is bacteria growing. All right, now this is a wheel type. But again, good applications inside a building, has to be in the northern states anyway. It's always good to have control of the weather inside. I've seen some of these where they have to actually heat up the water, okay? There's some other technologies out there as far as making algae even and harvesting the algae, and I haven't seen much on that one, but I heard about it. This is some of your equipment or blower type comparisons. What's interesting about all of these, these are all coarse bubble aeration. This is a membrane disc. Depending on the application, those will last maybe 5-10 years. But if there's a high chemical, they don't last very long. Same thing with these tubes. These tubes get plugged up. These get plugged up. This one here that I'm pointing at, according to the standard oxygen transfer efficiency, it was the most efficient. And all it was metal plate, and it popped up when the air came across it. Whoops. But supposedly, according to the information, that actually performed very well. It's a coarse bubble, okay, but obviously the cheapest, easiest to maintain, etc. These here, obviously no maintenance as well. It's all stainless steel, but anything with membrane, you're pretty much going to be replacing on a 5 or 10 year basis. And we've seen those broken off or whatever in the lagoon, floating towards the top, et cetera, et cetera. So when those tubes, which are usually these here, when they break off, now your efficiency to the rest of that whole system has just gone downhill, because now the air is going out of the weakest point. You have no resistance. So now the majority of the air is just going out to that one place, okay? So again, get a diver. There's divers out there that'll repair those for you. I'm guessing they're expensive. Again, the Sagar system out there. Anybody in here have a Sagar? No? Okay. This has been developed now for probably about 8-10 years, I'm thinking, 10 years. They're getting some good traction on it. And again, it's basically a very large sand filter, okay? Sand filter or a field like back home on the septic system, right? It goes through the old lagoons. If it's an upgrade, it's an old lagoon. And they put in their aeration, et cetera, which is fine. And they keep it all mixed up. And then there's media in here that absorbs all the nutrients as well. And these are pretty good as far as meeting your permits and ammonias. And I haven't heard anything as far as a phosphorus, but I assume that they would. Okay. Usually there's 2 of these. Okay. Because you got to let this rest at so many months, and then you're putting it into the other one. They're not cheap, but they work. They're kind of I would say they're probably a little less maintenance too. I have yet to see one dug up though too. Okay, if it fails, yeah, I've seen one of these being built, and I mean it's concrete walls. They're 18 feet deep. That's how deep these things are. They're very deep, with all different layers and all different layers of the piping and everything that's in there. Again, this is like an aero mix. It has an air blower into it. Again, years ago I worked for a company that created this technology to begin with. And another company basically stole this technology or changed it. The original piece of equipment, I don't. So it has a prop on the end, has a propeller on the end that spins, right? And so what they did, they put a shaft down in it. The original piece of equipment, and I have a few of them, it was a tube. And the tube and the prop spun together. There was no shaft. So you had no maintenance on that shaft and bearing that you have now. It's $1,500, whatever it is. So they so they changed the patent on it. So they put a shaft down the middle of it with a prop on the end. The original piece of equipment was a tube that spun with a prop. And so it created that vacuum in that tube as well. So this is where it all started, okay? That original company, they were doing hog operations and things like that with deep pits. Yeah, take care of the odor, but they missed a boat with municipalities is what they did. Somebody else got in there and did a good job on selling Aero Mix or Aero 2 or Tornado units. But, and then they decided they need a blower on it. What they're missing is they forgot about that technology of creating a vacuum inside that tube, okay? So now you're pushing this air into it. So now you haven't created a vacuum again. So they kind of defeated their own purpose. I haven't told them that. If they're listening, they might have figured that one out. I don't know. So the equipment that's being tested, standard oxygen transfer efficiency. It's a standard test for a lot of equipment, a blower, anything as a mixer, surface aeration. The thing it is the SOTE standard test was developed 20, 30 years ago. In today's world with new technology, that test doesn't mean anything to me anymore because it's also in clean water, okay? And we're talking about dirty water. We're talking about biological. Because to be honest, fine bubble, micro bubble diffusion, our MBD equipment, a couple of these other companies, because I've talked to them, and we all say the same thing. Our test looks like garbage. There'd be no reason it should ever work, okay? But when it comes to the biological process, that's where we shine, okay? So again, and then mixing. I have my own theory on mixing. Well, with this equipment here, we're homogenizing it, okay? We will move the water around this unit, and it actually pulls it up. We have different video of it, and in about 3 minutes or so, we had it in a 30-foot pool, and it had leaves and everything in it. In about 3 minutes, it started pulling these leaves just so slowly towards the center towards that unit. And then, it would pick them up, and even pick them up and toss them out. The interesting thing is nothing ever gets caught on these. We can put rags on it. There's nothing there for it to attach to. You could actually put your finger or hand on that unit. It might hurt, but it's not going to catch you, okay? So that's the other thing different about this equipment. We don't have to worry about it fouling or debris catching on it. This is an old site, an SBR system. What we did is we actually put in equipment. This is where their sludge, this is where they killed they've replanted the rebed, but this is where they killed it, by the way. And this is just emergency overflow. But we put in a single unit into their sludge tank. Over here by this building is a day tank. So this SBR system, they would aerate it, shut it off, and it would go through a denitrification, and then they would pull off the solids, and then they would mix it again, and then they would bring it up into the sludge tanks, and then they would decant even the water off of that. Well, they used to have a 20 horsepower mixer blower in there that would draw the air down in there, and they would cycle that about every 15, 20 minutes because they'd go septic on them. Well, we put in a single 2-horse unit and run it 24/7 and never go septic on them. So that's the other advantage of that site. This is what kind of happens. This is a wastewater treatment plant on a activated sludge plant. When we added the MBD to it, it made it cloudy. You didn't get as much separation, but all the separation was towards the bottom. And it's actually more compact even. This is very fluffy, etc. Something we tried back in 2004, okay? Again, lagoon conditions with MBD aeration. You know, we like to establish our plate count, our sim plate, our HPC, head trophy plate count. It's a starting point. We always do this as a baseline before we ever start anything. We look at, you know, reduce our H2S, ammonias, etc. Volatiles in the sludge. Your BODs, obviously. Reduce your TSS. Again, you reduce your algae if it hasn't already gotten out of hand. Sometimes it's a little difficult to get that back in front of it again. And again, reduces your turnovers in your spring as far as your odors, okay? Again, though, if you have 3 feet of solids or 2 feet, that's where the turnover is in the spring and fall, right? It brings it up. Once you reduce that, you'll get rid of your ammonia numbers. It'll reduce those. And your BOD and your TS and ammonias will come down as well. Because in the wintertime, the ammonia is coming off from your sludge that's left behind. Because after it's 40 degrees or less, your nitrous most bacteria aren't doing you any good, okay? Now, supposedly they developed cold water bacteria for ammonias, but I've never used them, so I don't know. So if they work, great. Some of the problems that we see with any of your sites, any of your wastewater treatment plants, is let's say you have a nursing home or you know, cafeteria, you know, maybe it's a manufacturer, or maybe it's, say, a locker, meat locker. Maybe you have some food operation. If they can pre-treat it before it gets to you or separate it, that'd be a plus. Because a lot of times they come in after your design has already been made, okay? And your design isn't made for their crap, all right? So if you can make them retrofit something to their system, or where they at least put it through a 5,000-gallon septic tank where it separates all the solids out and you end up with the water, that's a plus, okay? But, you know, when you get a high load from that company or that factory, that's where your problems come in. You know, your retention time is critical as well, okay? But yeah, if you're getting all your fat soils and grease from a restaurant, whatever, well, you know, that always causes problems with your lines as well getting to you, you know, so you're always out there cleaning those out. So make them be responsible for some of their own problems they're creating for you, okay? That's how I look at it anyway. So lagoon bacteria levels, you know, a low HPC usually is an odor issue. Odor problems come with a moderate plate count, may indicate more oxygen will solve the problem. If you have a high HPC or a high bacteria count, we've been in millions and billions, okay? And I always get the next complaint that we don't have any dissolved oxygen. Well, all that bacteria is consuming all the oxygen you can put in, okay, which is fine. You know, if you have a high oxygen rate but a low bacteria rate, well, then you're maybe not getting as much done as well, okay? At a certain point, you're wasting energy then as well. So this is a bacteria profile. Somebody in here might recognize it. So the chart on the left, you know, this lagoon isn't in very good shape. This is cell 1, this is cell 2. So it actually becomes a better bacteria format or life form in cell 2, but in cell 1 we have a problem, okay? So a month later, you know, we've done something different, and now it's all in good shape here in cell 1 and cell 2 as well. Again, we need to check your sludge blanket or your volatiles, because that will tell you what you know, mapping is always the easiest as far as, you know, sludge is part of your problem. If you're not getting rid of your sludge, you're not getting treatment. And if it requires doing enzyme bacteria, whatever that is, or adding equipment to it, that's what you need to be doing. I have this in twice. Interesting. Good thing I went through that fast. Again, your bacteria treatment, your food, your oxygen, temperature, pH, your retention time, your volume, etc. This is another lagoon. This is a 5 million bird operation. We've actually introduced our equipment in here. They still used their blower system because it wasn't working very well. Basically, it was all broken off or not working in these two cells. Over here, it's fine, but the rest of it wasn't. Appearance is everything. Maintaining your lagoons is always good. Keeping the grass mowed. Good rock coverage. You don't need animals to start digging holes in things. Seen it. Keeping your algae under control and your weeds under control. This is a operation that we introduced our equipment in. They have a blower system here, and they actually installed, they're like a half-inch hose with a lead weight to them, fine bubble, and you can barely see them, but you can kind of see a line through here. Well, this was next to a town in southwest of a town. This town was putting up with odor issues constantly. And we installed 4 units in the primary here and 4 in here. The water also changed. It used to look like this, but when we put these 4 in here, it became gray like that. But in about 3 weeks, we got rid of the odors from that site. They're going to be updated to a city stream, so it's temporary, but it was a 3-year temporary. After that point, after that 3 years, they didn't have to dredge it because the time that we were there, they were able to just mix it in with the dirt and close down the lagoon. So we saved them about $500,000 in that process. This is a real duckweed problem. This is a little bit out of control. All right, we have our aerators in here, our MBD units. They also had what I call coontails growing in there. And so it was actually getting, up towards the unit. It was 6 feet tall. So that was a problem. So you got to keep control of what's going on. I hate it when I see a bunch of grass and dead material going into the lagoons. That's always a challenge for a treatment process. Again, this is coontails that we pulled out of the center. It's actually growing, like I said, 6 feet. It's clear around this. But it's kind of restricting what the MBD could do, really. So, lagoon cover options. I don't know if some of you might have seen some of these are balls. I meant to bring some. They're plastic balls. Some are round balls. Some are a hexagon shape, and they interlock with each other. These are starting to get used more and more. This prevents the algae and duckweed from growing on your lagoons. Okay, it actually helps with your, with your BOD TSS because now you don't have the green water. Okay, so, and it'll also help with your ammonias because now it's keeping your water temperature up as well. I've heard different things about them, okay, but they're being used, and they're being used more often. Bacteria environment, obviously got enough oxygen, got enough food. The bacteria will divide every 20 minutes, okay, providing it has air, food, and water. So after a certain time, you get into this potential growth of bacteria. And one bacteria has to take care of the BOD first before it can take care of ammonia, okay? It becomes an assembly line. Again, retention time. Limitation of it, lack of water, lack of time, violent mixing, temperature, obviously, any chemicals or polymers that are in there are going to affect your environment as well. Again, industrial waste, food processing, meat lockers, cafeteria, nursing homes, schools. Both of these are putting a lot of bleaches and everything else down the drain. You know, sanitizers, you know, bleaches, even truck washes, septic tank. I have a couple sites where they allow the septic truck dumping their lagoons. You have no idea what they're dumping on you. And unless they're paying you big bucks to do it, don't let them do it. A lot of these lagoons aren't equipped to handle that surge, okay? There's one here in Illinois that they allow it, and it's just a real problem. And I told them they need to take it to an actual treatment plant where it belongs. But, because they could have everything in there. You know, could be a grease trap from restaurants, okay? So, which I have a suspicion that's what it is. But yeah, in today's world with COVID-19, we're getting a lot of sanitizers and bleaches down the drain, okay? So if you want to look at, you know, the health of your lagoon, the only way to do that is look at your play count and maybe and see what type of bacteria you have in there. Again, pre-treated aeration type. You got, you know, you probably have to add enzyme bacteria nowadays just because of COVID these days. So here's the two lagoons that we looked at as far as looking at the profile of the bacteria. So the one on the right turns this color many different times. Okay, this has happened 3 or 4 times. And then once we get enough aeration to it and enough going on, it turns back to a normal color again. What's interesting, that color never changes in cell 2, but that's okay. But yeah, somewhere something happened to that lagoon that killed it. You know, we kind of know where the source is coming from, but it takes time to get it back to a healthy state. That's just another close-up of it. So yeah, you want your free swimmers in there. Your ciliate, rotifers are always good. Again, there's that chart. So, aeration equipment, values, performance. What's your capital cost of the equipment? What's your operating cost of the equipment? Okay. What's the efficiency? VFD controls. This is one of the other things I've been talking to with other different clients. If you throw on a 50 horsepower blower, okay, you're being spiked and you're being charged on that spike for that month. So get with the Illinois electric companies, or there's different groups. Get a VFD on that or soft start, okay? Because there's no reason you need to be paying for that 50 horse spike, okay? I've seen it ever so often, and I just cringe because they don't realize what they did. But, you know, sometimes they have 2 or 3 blowers, and they're like, well, we'll turn on this other blower. Well, it's another 50 horses, okay? And now you just spiked it for that month. So now you're paying on that rate, on that spike. So get some VFDs or soft start control units in there. That'll help with your electrical costs. And it'll save you a bunch of money. It'll pay for itself in a short period of time. So what's the age of your original equipment? You know, what type of upgrades are you looking at? How well do they perform in cold conditions? Again, what size, you know, what's the depth of your lagoon? What's the size of it? Retention time falls into that. What's the standard, what's the SOTE of that equipment? We'll provide it for you. We provide it for our engineers all the time. I said, you won't like it, okay? But, you know, reality is you know, we do a big benefit for a lot of our clients. But the depth is also important. If your lagoon is 5 feet deep or 6 feet deep and you have an engineer try and tell you to put in a blower system, find a different engineer, okay? because of the efficiency, it takes at least 10 to 12 feet of water for that air bubble from the bottom to scrub up and get the efficiency out of that air bubble. Otherwise, you're just wasting a lot of energy, okay? So don't get me wrong, if you want to put a blower system, that's great, but your lagoons need to be 10 or 12 feet deep, so to be beneficial. That's one of the benefits of, MBD is where you start from the surface and go down. We've done a lot of applications where the lagoons are only, 4 feet deep or 5 feet deep, and so we're able to make those changes for them. So again, depth of the lagoon, retention time, what's your conversion options, repairability, additional blowers, blower pipe size. I always see there's one site, the size of the pipe is 8 inches, but yet they have 3 blowers. Well, you can turn on the first one, you're going to get every cubic feet of air going through that pipe from that blower. You turn on the second one, it's a little bit less. You turn on the third one, the amount of air from that third one is not going to affect it as much, okay? You can only blow so much air through a straw, right? That's all there is to it. That straw is the same size, you can put 4 to it, but you're only going to blow so much out of that one straw, okay? So sometimes I tell people to slow down their blowers. They're more efficient. The slower you can make that air bubble rise, the better off you are. It gives it more time for the surface. So here's a typical blower system. Again, they had broken. There's pipes above the water, et cetera, 30 horsepower blowers. And then we put in 3 MBD units. This is exactly a year later. There's just one here, one there, one there. This is cell 1, 2, 3. And it changed it by quite a bit. Got rid of the duckweed, got rid of their ammonia levels. Didn't get rid of them, but we reduced them because of the solids in there. And there's the 3 blowers. That pipe is all the same size. Again, winter condition. Here's an arrow too. I don't know how many of you have these out there, but in a harsh winter, I see a lot of these, so you're not getting any treatment now. If you lose your power, you're never going to get it out. This is surface aerators, Denver, Iowa. This was actually split. So half of it went here, half of it went there. So they had 4 of these in cell 1, cell 2. And we put in 3 units, I think, here and 2 in here, actually. But we changed, both of them had the same problem with the duckweed. But on our side, we're actually lifting that solids up into the water. That's why the water is a little different of a color, which also actually helps reduce your algae problem. In order to change out any one of those surface aerators, it takes this much equipment and people to do it. In the winter time, that's what surface aerator does. You're not getting much of an oxygen transfer as well. And these were only 5 feet deep as well. So we had to do an emergency install. So we cut through the ice with a chainsaw. Right there is 12 inches, 13, 14, all right? It can be done. We cut a hole in just really for the aerator to fit down. This is way back in '07. But we installed that one the day before, okay, and it melted that much ice around it, okay? But yet the ice was still this thick over here. So don't get too close over there, though. So we were able to get, transferring air and oxygen into the water underneath the ice. This is a different site. It got converted from a controlled discharge to a continuous discharge. I didn't really care for the setup, but cell 1, cell 2, and then they put a curtain across here, et cetera. And this was late in the summer, so the algae was already there, et cetera. This is Ashton, Illinois. This was back in not too long ago. As you can see, they have 2 units in cell 1 and 1 in each cell working. That's all that was operating in there. Okay. The rest of these that were junk. So in about 40 days, 5 weeks later, we installed the NBDs. We used the same electrical that they had for these guys. And 5 weeks later, we've turned this water into a different color. Again, we've started lifting the solids and everything up into the lagoon. And so you can see some of the stuff breaking up around here. This is just a typical MBD installation. This is actually also in Illinois. This one here is where they actually let the septic truck dump, and that's a real problem. The lagoon isn't big enough for them. And then the rock filters need a little attention, all the duckweed. Mechanical plant, our clarifier system. We put a unit into their day tank type of operation where it goes back up in here. The lagoons are after the treatment because they had quite a few bit of solids in their lagoon here. And then it flows over here and then on out to their stream. So the application can be pretty much anywhere you want to. Just another wastewater treatment plant. They draw all their water off of this lake, actually, and they put it through their system then. So just kind of keeping the water fresh as it went. Illapis, Illinois. They had a blower system again that was failing. Lots of pipes broken again. We actually had another unit in here, so they got 4 units in here, but we only had a single one here. Reduced their electrical, obviously, and help with their limits as well. This is actually an overkill on electrical that we usually do. Normally, we just tap into what's already there. But since they didn't have anything out there, we had to put in electrical process. So, this is a nursery hog operations. So we can see the BOD in a short period of time from April to June as far as a reduction. From 12,000 BOD to around 1,500 BOD. Same thing with suspended solids. Again, we measure the plate count, and of course in the hog operations, it's all good stuff. It's not municipal, but we went from over 500,000 to 3.5 million. That's the things you want to see once you change something. You want to see a change in what you're testing for, and plate count's a good one to measure. So that was a hog operation in June, and that's in November. This is a brewery. I like breweries again. I like my beer. So a brewery puts out about 4,000 BOD loading. Okay, that's pretty heavy stuff. So yeah, we put in 12 of these on this lagoon. I think there's 10 on another lagoon. So again, the lagoons almost weren't big enough for the operation. And there they are all lined up actually. This is an application in a liner. If this site was draining they were draining their water down for emergency reasons, so we put a little air to it to keep it fresh as well, so that when it comes back into the plant, it's not an upset. Again, this was Denver, Iowa. This was just a reduction in sludge over time from 03 to 05. And again, this is a plate count that we did, and we were measuring this every week. So in January it was nothing, but we measured again in May, 19th and 22nd, or 26th, and then on the 3rd of the week, it always seems like the 3rd or 4th week is when things start jumping. So, and then of course, we did it 10 days after that, and it jumped again. So we're almost to 2 million on the plate count. Okay. Again, the MBD transferring oxygen in underneath the ice, in cold water and actually keeping it melted. So again, types of aeration. You got surface, blower, diffusers, coarse bubble, micro bubbles. You have ceramics, you have nanobubbles, and they all conform with the SOTE. This is just a little pre-treatment type operation. I wish it was deeper. It would have been more beneficial. But, this is only like 10 by 20 chamber, but if that's all you need to do, then so be it. But that's fine. Air bubbles. When you first start to boil water, the bubbles that you see are basically air bubbles. Technically, these are bubbles formed from the dissolved gas that are out of the solution. So again, as we saw, as I mentioned, are provided, they become all over the place as far as the water molecule. This is just a site questionnaire that we always hand out. We want to know who it is and what it is and what type of system it is, gallons a day, your fluent, what your limits are. We'd like to know what cell is depths and all that good stuff. And also, we'd like to put the sonar in there to know exactly what we got. This is an egg operation that we did back in 2012. One of the pits, it was coming out of a covered digester, and it never produced any gas. And then we went to an aeration pond, which was with the MBD, and pit 5 was the effluent from that pit. So basically, we started out at 2,700 milligrams per liter down to 75 in about 8 months. It takes time to do that. This is some of the stuff that we look at. This is documenting a lot of things that we did with that operation. What the BODs were, play counts. Again, now this site's up to 14,000 BOD. Okay, and we're still using the same footprint, and it's not working now, of course. You can't pour 2 gallons of poop in a 1 gallon. Okay, it's not going to work. Okay, so we're having discussions today on it. One of their other problems is electrical. They don't even have enough electrical to run everything we need. So this is just a bar and grill application. The BOD came in around 1,000, going out at 92. The TSS was 132 down to 48. And the fast oil grease was coming in at 84, going out at 2.5. And then it goes to a mechanic or a municipality. So again, it's just a 1,500 gallon tank, adapted it with a MBD unit, and move on. We got other different weird things out there, oxygen infusion. If you're going to put this with your blower, it's kind of worthless because it's just going to go to the surface. We do the same thing. We can actually attach pure oxygen to our equipment into that partial vacuum bubble, and it's going to be there for a long period of time. On the SOTE test that we do, that we've done in-house even, as soon as we hooked up a oxygen purifier or oxygen that makes oxygen, just like at home, okay? Because normally it takes us about 2.5 hours to meet that standard. You got to get up to 8 parts of DO, okay? And it takes about 2 hours, 2.5 hours to get there. Once we introduce pure oxygen to it, with an oxygen concentrator to it, and we were recirculating the waste bubbles as well, I call them, we got it down to 12 minutes, okay? So that's how, that's one of the other benefits of adding pure oxygen to one of our equipment is now it's under a partial vacuum and it's going to sink into the water, and now you're going to have all this high oxygen bubbles going in the system as well. So one of the other things to do to up your auction out at the creek is just make a stair step, okay? That's the simplest, one of the simplest things you can do to meet your 6 bar for DO. Just go ahead and put it in a stair step. You know, it doesn't take much to do that. Be pretty inexpensive. Again, understanding your biology, your bacteria, your dead zones, ammonia, your water treatment, you know, again, your sludge. This was actually clear back in, we actually started this back in '02, but that's just a picture of it. They do about 400,000 gallons a day, typical 200 pounds of BOD, and you know there's only 5 units here and 2 in here. Okay, they had a blower system before. It was an old Heinz coarse bubble system, and that was 30 horses, and now they're down to 14. So again, this was Ackley. This was, and again, this was measured by People Service, their company. So they had an average before we started, and we actually started the system in October, November. And in 6 months or 5 months, we reduced it 5 inches in cell 1. And then as time went, we got it down to less than 5 inches throughout the lagoon. Of course, now with the sonar, we know what we actually have. So again, this is a play count that we started with. Cell 1 was the only cell we actually implemented the MBD. So this is in November, December, January. This is northern Iowa, okay? So the play count boosted up here in the winter months, and it also boosted up in cell 2. They were traveling over there. The oxygen bubbles were also traveling to cell 2. So we're getting this effect throughout the whole system with the MBD. Again, 3 million bird operation that we do. There's a 6.5. So we help you try to solve some problems if we can't. I usually know some people that can help you. I always have referrals. Don't trust everything I tell you. But I hope you have, you know, some thoughts and take a little bit away from what I've mentioned here today and give you options. So that's the end of my routine. Thanks, everybody.